Hello there, and welcome to my pedagogical content presentation. I would like to address students and teachers today about different strategies and methods using long division, primarily using multi-digit numbers. We're going to start with the standard algorithm, and we're just going to throw out some numbers here. So we'll do 21, and let's just do 1, 2, 3, 4. For this method, we are primarily trying to see how many times this divisor can go into this dividend. So 21 cannot go into 1, 21 cannot go into 12 because this number is too small. So 21 can go into 123. We just need to figure out how many times it can. I don't know my 21 multiplication facts, so I like to come over here and just start multiplying numbers to see how close I can get. I think we could go a little bit higher. Let's try to see if we can go a little bit higher. So 21 times 6 is too big, so we're going to take 5. So we're going to put 5 above here, write 105 down here. 13, 12, 11, 10, 9, 8. Bring down your 4. Now we're trying to see how many times 21 can go into 184. We already know that 21 times 6 is 126, so let's see how much higher we can go. So 21 times 9 is too big, so we're going to take 21 times 8, which is 168. Oh no, my pen is dying. $14, 13, 12, 11, 10, 9, 8, 7, 6. 21 cannot go into 16 because 16 is too small, so we have remainder 16. So our answer for the standard algorithm is 58, remainder 16. For the next method I would like to show is the partial quotients. This method is probably my favorite, especially when you're using multi-digit numbers, to keep the consistency and show students that whatever method you choose to use, that you can get the same answer. So we are going to use the same numbers. And essentially for this particular method, we're trying to see how, what kind of chunks we can take out of our divisor, or excuse me, our dividend. So I'm going to come over here, and I usually like to suggest starting with a bigger number. I usually like to use 100, but I already know that in this case 100 is going to be too big, and that is the one rule that I have when you're using the partial quotients method, is that whatever chunk you choose to take out of this, it has to be smaller than this. So let's just start with 50 and see where that gets us. Please tell your students to circle this. It's very vital to kind of wrap everything up at the very end. 21 times 50 is 1050. And we're going to take this number and we're going to write it underneath of here. You're going to go ahead and subtract. 13, 12, 11, 10, 9, 8. Now we're trying to see how many times 21 can go into 184. So from our previous method, we know that 21 times 8, make sure to circle that, is 168. And we're going to take this and we're going to write it underneath of here. You're going to go ahead and subtract. 14, 13, 12, 11, 10, 9, 8, 7, 6. So we know that 21 cannot go into 16 because 16 is too small. So this will be our remainder. Now, for the circled numbers, we're going to take these, and regardless of whatever numbers you circle, you will always add them up at the very end. And that will be your answer. So you have 58, remainder 16. Again, for this method, make sure that whatever chunk you choose to take out, the answer has to be smaller than this dividend. For our next method, we are going to be looking at the grid method, also known as the box method. For this one, please encourage your students to give themselves plenty of space. And again, we're going to use the same numbers for consistency to show that regardless of whatever method you do use, that you will get the same answer. So for this step, we're going to be looking at 21 and how many times it can go into 0. It can't, so we're going to put 0 above here, and you're going to minus 0. You're going to take the remainder right here, and we're going to plug it into this box right here. Now we're going to be looking at how many times 21 can go into 12. Well, it can't, so we're going to put a 0 here, put a 0 here, and then we're going to go ahead and minus that. Now we're going to take this remainder, and we're going to plug it into this box. And now we have 123. This might start to look a little bit familiar from our previous methods. So now we're going to look at 21 and how many times it can go into 123. Well, we know that from our previous methods that 21 can go into 123 5 times, which is 105. We're going to go ahead and subtract that. 13, 12, 11, 10, 9, 8. We're going to plug this remainder into this one right here. And now we're trying to see how many times 21 can go to 184. From our previous method, like I said before, we know that it'll go 8 times, which gives us 168. We're also going to subtract that. 14, 13, 12, 11, 10, 9, 8, 7, 6, 1. Well, we know that 21 cannot go into 16, and there's no other numbers to plug this in, so we know that this is our remainder. So our answer is 58 remainder 16. One downside I have noticed that when we teach students the different methods and strategies is sometimes they start to blend the strategies together. So my only suggestion when it comes to that is to make sure that when you're teaching these methods, encourage your students that when they already know a strategy or a method really well, just tell them to stick with it and leave the rest. My other suggestion is to please encourage your students to use grid paper. It keeps their work really neat and clean. I've noticed that when they're just doing it like this, their work gets a little sloppy and they kind of get messed up. But anyways, I hope you like the strategies, and thanks for watching.